Hey everyone, so every single day we're online, sending emails, browsing websites, moving tons of data around. But have you ever stopped to think about what's standing guard between your computer and the absolute chaos of the open internet? Well, today we're going to pull back the curtain on one of the most critical pieces of cybersecurity out there, the firewall. Let's get into it. So, we've all heard the word thrown around, probably for years. But what is a firewall really? What is it actually doing, minute by minute, to protect us? When you boil it all down, a firewall is basically a digital security guard. It's that critical first line of defense that sits right at the border of your network. Its one and only job is to look at all the little pieces of data, the packets, trying to come in or go out, and then decide, do I let this through or do I shut the door? It is the ultimate gatekeeper. And this gets to the fundamental problem that every firewall has to solve. I mean, think about it. The most secure network you could possibly have is one that's completely cut off from everything else, right? A total lockdown. But that's also completely useless. So the firewall's job is to manage this constant tug of war between absolute security and the controlled, necessary access we need to actually get things done. So here's how we're going to break this down. We're going to start at the ground floor with the most basic type, the packet filter. Then we'll level up to proxies and application gateways. And finally, we'll see how you can combine all of these to build a true digital fortress. All right, let's dive into our first level, the packet filter. The best way to think about this one is like a bouncer at a nightclub. Their job is pretty simple. Check IDs at the door. This bouncer isn't interested in a deep conversation. They're just looking at the basic info on your ID. In this case, the packet's header. They're checking things like, where did you come from? That's your source IP address. Where are you going? That's the destination IP. What door are you trying to use? That's the port number. Based on a simple list of rules, it's a quick yes or no. It's very fast, very efficient. Okay, but even with this simple bouncer, you've got two different flavors. The first is a stateless filter. This one treats every single packet like a complete stranger. It has zero memory. It doesn't care that it just saw a packet from you a millisecond ago. This new one gets examined from scratch. But then you have a stateful filter. This bouncer is a lot smarter. It actually remembers the conversation. It knows, hey, someone from inside my network just asked for a web page, so it expects a response to come back. This ability to track the state of a connection makes it way, way better at spotting things that just don't look right. Okay, so that's our bouncer. Let's level up to our second type of firewall, the proxy. This isn't a bouncer anymore. This is more like a highly secure middleman who handles all communications for you. It's a totally different strategy. Now, this is the really crucial part to understand. When you're using a proxy, your computer never makes a direct connection to a server out on the internet, ever. Instead, you connect to the proxy. The proxy then turns around and opens up a completely separate new connection to that server on your behalf. It acts as a go-between, relaying all the information back and forth. What this does is effectively make your internal network invisible to the outside world. There's just no direct path for an attacker to get in. And because it's sitting right there in the middle of the conversation, a proxy can do a whole lot more than just pass data along. It's like a Swiss Army knife. It can store or cache copies of popular websites to make them load faster. It can demand that users prove who they are before letting them out. It can keep detailed logs of everything that goes through it. It can even handle all the heavy lifting of encryption and decryption. It's a seriously versatile piece of kit. And that brings us to level 3, the application gateway. So if the packet filter is our bouncer and the proxy is our middleman, this is the super intelligent content inspector. This firewall actually understands the language being spoken. This is a total game changer. An application gateway doesn't just glance at the address on the envelope, the IP header. No, it carefully opens the envelope and reads the letter inside. It understands the specific rules for web traffic or file transfers or email. And it can make incredibly detailed decisions based on the actual content of what's being sent. The secret sauce that makes all this possible is a technology called Deep Packet Inspection, or DPI. This is the superpower of the application gateway. It's the ability to look past the mailing label and inspect the payload, the actual stuff, the data that you're trying to send or receive. And this is exactly why DPI is such a big deal, because this firewall can literally read the data. It can spot malicious code hidden inside a file you're downloading and just block it. It can enforce rules about what websites people are allowed to visit. And it can recognize the digital fingerprints of known attacks and shut them down before they can do any damage. It's a much, much deeper level of security. So we've got these different types of firewalls, and they each have their strengths. But for real, top-tier security, you don't just pick one. You combine them. You build a fortress. And we're going to look at a classic design for this called the multi-stage firewall model, often known as the PAT model. Just look at this flow. This is what we call defense in depth. Let's play this out. Say an employee gets a phishing email. The first firewall, that external packet filter, might let the initial email through because, hey, it's just email traffic. But when the employee clicks the malicious link, the traffic now has to go through the application gateway. This is our content inspector. It performs deep packet inspection, sees the signature of malware inside that data, and bam, it kills the connection right there. The threat is stopped cold before it even gets a sniff of your internal network. So let's break down the job of each component. That first packet filter, PF1, is like the frontline soldier. It deflects all the basic noisy attacks, which is crucial because it keeps the much more powerful application gateway from getting bogged down. The ALG can then focus all its brainpower on hunting for those really complex hidden threats. But here's the brilliant part, that internal filter, PF2. Its job is to protect you from yourself. If a computer inside your network gets infected somehow, PF2 can stop it from attacking other machines on your own network. It contains the breach. This layered approach is the absolute gold standard for a reason. Now, of course, building a fortress like this, it's not cheap, and it's certainly not simple. But there's a trade-off. What you get is a vastly superior level of security. It's built on this core principle of defense in depth, which means an attacker doesn't just have to beat one defense, they have to beat multiple, different kinds of defenses. For any serious organization, a single point of failure just isn't an option, which is why this model, despite the cost, is so essential. And that brings us to our final thought for today. We've seen firewalls evolve from simple bouncers to these complex, multi-layered fortresses. But here's the thing, the bad guys are evolving too. Their attacks are getting smarter, sneakier, and more sophisticated every single day. So the real question we have to ask ourselves is, what's next? How will our digital gatekeepers need to evolve to keep us safe tomorrow?